We're going to discuss finding the nature of the roots of a quadratic equation. So this strange sentence here kind of begs the question, what does a root, what does that mean? So a root has many synonyms, and I wrote them all over here in this little cloud. A root is basically the answer or the solution to your polynomial equation. So if we are solving for x in the quadratic equation, we would say that x equals 5, x equals 8, whatever it is, that is the answer or the solution. But we can also say that that is the root. Other words that we use are zeros and x-intercepts, and these guys here are especially used when we're graphing, and we're going to be graphing soon. Just know that all of these mean the same thing. We talk about a root, we're referring to the answer. So if we want to know the nature of the roots, then they're kind of asking what kind of roots are we going to have? Well, for that, we're going to use the discriminant. The discriminant is b squared minus 4ac. So this discriminant is the part underneath the radical sign in your quadratic formula. When you plug in for b, a, and c and get a number, that number will help you determine two things: how many roots there are and what kind of roots. So basically, what number set do they fall in? Well, let's just remember something. How many roots there are. A while ago, when we first started quadratics, we said there are three things that we want to link together forever. The word quadratic, the x squared, and the parabola, which is the graph. And it's this U shape, and it can open up, and it can open down, and we are going to be graphing pretty soon, but just remember linking these three words. So the quadratic formula is for x squared, and we also said, hey, if I have an x squared, I am expecting two answers, two solutions, two roots. And if I don't get two roots, then there's a logical reason why. Okay, so coming back to this, we want to know how many roots there are. Well, there's either going to be two, like we just saw, or maybe there's one, or maybe there are none. When we want to know what kind of numbers they are either rational numbers. Remember, rational numbers can be written like a fraction, a over b, whatever it is, or the numbers can be irrational. And remember that irrational numbers are either numbers like pi or something like the square root of 7. It's the square roots that you can't do. Irrational numbers do not repeat, and they continue on forever and ever. Okay, so here is the story. When you figure out what this number is here, what that discriminant is, don't take the square root. Notice there's no square root here. B squared minus 4ac. When you figure this number out, it could be a few different possibilities. First of all, it can be a positive number. And if it's a positive number, then there are two roots, two solutions, two answers. If that positive number is a perfect square, 16, 25, 49, want any perfect square at all, then that means you can, in the quadratic formula, actually take the square root of that number and the square root symbol goes away. Then you're going to have two rationals, two rational roots. If that positive number, b squared minus 4ac, is not a perfect square, like any other number, here are some examples, then when we, in the quadratic formula, go to take the square root of any of these, the radical does not go away. And since we keep the radical in our answer, we are going to have irrational roots. So positive numbers will give you two roots. Perfect squares are rational because the radical goes away. Not a perfect square is irrational. Okay, well, if your number is not positive, maybe your number is 0. And if it's 0, then there is one rational root. Square root of 0 is 0, right? So you're not adding or subtracting anything in the quadratic formula. One rational root. If your discriminant is a negative number, any negative number at all, there is no real number solution. So in Algebra 1, we are only dealing with the real number system, so there is no solution. All right, let's do an example for each one of these possibilities. Okay, so we are going to determine the nature of the roots, which means, are they rational or irrational, or maybe no, pointing to nothing, or maybe there's no solution at all, and how many are there? Okay, are they 1, 2, or 0? Okay, so let's start here. So for this one here, we are only going to do, remember, the b squared minus 4ac, because we are doing the nature of the roots. That's using the discriminant. A, b, there's nothing, and c is negative 4. Plug it in here. B squared minus 4 times a times c. That means nothing. Negative 4 times 1 times negative 4, this is positive 16. You could put it in the calculator if you want to. So now the first thing I notice is that there's a positive number here. Positive number means 2 solutions. Then what I'm going to also notice is that it's a perfect square. If you're not sure, try it in the calculator. Right? Take the square root of 16 in the calculator and see if you get an integer. So then there's going to be 2 rational roots. Okay? And that's what this one is here. Here's our next case. Remember, we're doing the b squared minus 4ac, not the whole quadratic formula. 6, negative 2, and negative 1. B squared is negative 2 squared, remember that's 4, minus 4 times a times this negative 1. So minus this times this times this, well that's negative 24. Whoops, that would be minus a negative is plus a positive, that's 28. So now what I'm seeing is, okay, well this time again I have a positive number, 2 solutions, but this I cannot take the square root of and have the radical go away. I can simplify it, but because it's not a perfect square, I will have irrational solutions, 2 of them. Moving on. Let's do numbers 3 and 4. 4, negative 12, and 9. Notice for all of these examples, in order to pull out your a, b, and c, these equations have to be equal to 0. For our examples, just to make the videos a little shorter, even though I'm elongating it by doing all this talking, I made them equal to 0. But just make sure your whole equation in standard form, x squared x, number equals 0. So now we're going to do b squared, negative 12 squared, well that's 144. Sometimes I just say that. Minus 4 times a times c. Let's see. I have no idea what that is. We're going to check this out. So we're going to do 144 minus 4 times a times c. 0. Those are actually in order. So there's 0. So when I look up above, that 0 means that there's going to be one solution, and it is a rational number, meaning no radical in the answer. It's going to be some fraction or some whole number, some integer. Number 4, 5, 12, 10, b squared minus 4 times a times c. Let's see. So this time I have 144 minus 4 times 5 times 10, negative 56. As soon as I get a negative number for my discriminant, that's the number under the radical, then there is no solution. There is no real number solution, so in Algebra 1 we say there is no solution. When you get to Algebra 2, then we kind of say, well, you know what, there should be some kind of answer that we'll be able to write there, and that's when we come up with the imaginary number system. We are not doing that in Algebra 1, but sometimes you will see 2 imaginary roots. So if you see that, then this refers to something we're going to be doing in Algebra 2, but in Algebra 1 we just say that there's no solution, and to be super clear, we say no real solution or no real number solution, and that's why we wrote that up here.